So we're going to do this practice problem, describe the bond that occurs between hydrogen and bromine in HBr. If you remember, the one in the pretest said the bond between hydrogen and chlorine in HCl. Very, very similar. So we're going to do this one together, and then you should be able to do the one in your pretest by following this example. So the reason I want to do this together is because this question sounds really simple, but we're actually going to use everything we know from Unit 1, Unit 2, and Unit 4 to answer this question. So we want to be able to describe and show what this bond looks like. And to do that, we actually have to go all the way back to Unit 1, where we learned how to do orbital diagrams. So if you remember orbital diagrams, those are the things that were like these circles. And then remember, we added the electrons one at a time. And then I said, how many half-filled are there? And you were like, 3 unpaired, and you had no idea why that was important. Well, now we're going to learn why it's important, because that's where bonding happens, right? They're unhappy. If they could just fill that up, they would be so happy. So we're going to learn that, use that to learn this new stuff. So what we want to do is we want to draw the orbital diagrams for H and for Br to look at how they might share their electrons to be happy. So to do that, we're going to look up first. Hydrogen is in the S block. It's in the 1s block. So I'm going to draw that orbital diagram. I know this is you're going to have to go back into your memories here, but anytime there's an S sublevel, remember that's one orbital. It'll have one orbital there. And because hydrogen has 1 valence electron, we're going to put 1 dash in that orbital. That slash represents the 1 valence electron that hydrogen has. And we actually only have to draw the valence electrons because those are the ones involved in bonding. So that's hydrogen. And then we're going to do bromine, which bromine is in the 4th period, all the way over here in the halogens. Okay, so it's in period 4, but it's in the P block. So it has 7 valence electrons. And those valence electrons are going to be in 4s and 4p. If you need to review that, that's from Unit 1 and Unit 2. So anytime we have an S, this line is not straight. Anytime we have an S, that's 1 orbital. Anytime we have a P sublevel, that's 3 orbitals, if you remember. Okay, so we're going to put these 7 valence electrons. So remember, if you remember how valence electrons work, it would be 4s2, 4p5, right? So we're going to put 2 electrons there, 4s2, and then 4p5. When we count to 5, we have to count 1, 2, 3, 4, 5. We give each electron its own room before we double up. That was all review from a long time ago, so if you don't remember that, it's okay. You can go back and review, but really this is the type of question that you need to be able to answer, so you could just watch this video again since I'm recording it. Okay, so then what we want to look at is how could H and Br share electrons so that they are both happy, right? And we were taught to look for unpaired electrons. So you see hydrogen has an unpaired, and you see bromine has an unpaired electron. So what they're going to do is they're going to share that pair together. Okay, by sharing that pair, right? Imagine that H's electron is in Br, then Br is going to feel like it has an octet. If Br's electron goes to H, then H will feel like it has a complete energy level. The first energy level would be complete. So by sharing, they'll both feel complete and happy. So this is why unpaired electrons are really important for us to look for. All right, so hydrogen's 1s orbital overlaps with bromine's 4p orbital. So that's one thing we need to show. The other thing we need to show is we're actually going to draw a picture of what this looks like using orbital shapes. Again, review from all the way back from Unit 1. So the s orbital is the really easy shape. It's actually just a circle. So we're going to draw a circle to represent hydrogen's 1s orbital. So this would be hydrogen. And then we're going to draw bromine's 4p orbital that has this electron. The p orbitals have that funny dumbbell shape. It kind of looks like an infinity symbol. So we're going to draw that overlapping with the s orbital. So you want to have them overlap. So that's showing that they're sharing electrons there. So this is bromine. So this 1s orbital, that's why that one's a circle. And this 4p orbital is the dumbbell. So then what we also want to include is this bond between the H and the Br, right? This bond they're sharing electrons, so it's covalent, but it's not an even sharing. So when they're sharing these two electrons between them, it's going to be closer to one side, and that's what we call a polar covalent bond. Polar means unequal. And that's because they have different electronegativities. They're pulling on the electrons differently. And so we'll show how that plays out here. So since this is a polar covalent bond, forgot the word bond, we want to show which side is partially negative and which side is partially positive. So bromine here is pretty good at tug of war. It's more electronegative, we know, because it's very close to fluorine, which is the tug of war champion. So since bromine is more electronegative, these electrons that they're sharing are going to be closer to this side, which means this side is going to develop a partially negative charge because more of the electrons are getting pulled towards bromine, whereas the hydrogen side is going to be partially positive. So you always will have one side that's partially positive and one side that's partially negative if the bond is polar covalent. Remember, if it was non-polar covalent, like if you had a situation where H and H were sharing electrons, then it would be non-polar and it'd be equal and you wouldn't have these partial charges. Okay, so that's pretty much it. I have on the slide I'm going to upload after school, it has some words on it that I'll show you. But really this, if you understand this part, that's what's really important here. All right, so that's our first, here, I'll show you the words. Oh, I'll show you how it looks here on my pretty slide that I'll upload later. But you want to make sure you can understand and answer a question like this, which there's another one for you to practice on your pretest packet. But we're going over it now, and it's on your pretest, and it's a very good problem that combines a lot of knowledge from many units. So the other one I'm going to walk you through is actually directly from the pretest. So it's this one, number 6. So it says, in terms of bonding, why does the element oxygen always appear as a diatomic element? We learned diatomic elements, Brinkelhoff, they always come in pairs. So it's like O2, N2, Cl2. And it says to explain why that is using orbital diagrams. So we're going to use orbital diagrams again. This time we're going to use the orbital diagram for oxygen. So we're going to find oxygen. It has 6 valence electrons and it's in the 2p block. So it's going to have its 2 s electrons as valence, and it's going to have 2p electrons. So we've got 6 valence electrons. So in the 2s, that's going to be full, 2s2. And then 2p6 would be the rest of its valence configuration. Or sorry, 2p4, not 2p6, 2p4. So we're going to count 1, 2, 3, 4. Remember, Hund's rule says to fill them all halfway before you double up. So in this question, last time we drew H and Br to show the bond between them. Here, we want to see the bond between O and another O atom, because we're trying to show why it's diatomic. So we're actually going to draw another O orbital diagram. So we want to draw the same orbital diagram because we're trying to understand why O would want to bond to itself. 1, 2, 3, 4. Okay, so again, our eyes should always go towards the unpaired electrons. So we see they have 2 unpaired electrons. And if they share, it could benefit both O's, right? They could share this pair, and they could share another pair. So if they're sharing 2 pairs, what kind of bond did we just make?
Double bond.
Yeah, a double bond. And if you drew the Lewis structure for oxygen, which you have in your homework, you will see that it indeed has a double bond. So now you can see why it has a double bond. And you can see why oxygen would want to be paired with another oxygen. So this forms a double bond. Pretty cool. So this question, this type of question, we just did the one that's actually in the pretest packet. So you could copy that into your pretest once you open it up. But if you want more practice for this style of question, just replace oxygen with any other diatomic element, and you could do the same thing. To draw the orbital diagrams and do the Lewis structure to show how those relate and how they would share their electrons and why they would be diatomic. So remember, that would be hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine would all do that. But you might get a different type of bond for each of those. Okay, so that one's kind of cool. I'll show you my fancy version here that I will post after school. Words, but again, the words aren't as important as long as you understand what you're drawing here. And that's how we get a double bond.